All right, you guys, we're going to kind of start something different in this chapter. We're kind of moving away from integration techniques, and we are going to start doing a little bit of statistics, which I say that with a bit of a laugh because I'm not a statistician, and mathematicians and statisticians are very different. But this is going to be kind of fun. I think this stuff is pretty cool. I know that you've read through the book already, so I just want to kind of talk about some important things about what you've read about. So what I want to do is maybe do a couple definitions. So you've already read about, do some definitions, and then I know this is going to be very unusual, but I'm going to do just one example and call it good. So, so let's do some definitions here. So let's consider experiments. So I'm going to kind of summarize what they did in your book. Okay, so I expect you to read the book. I expect that you will have read, about the mean, which is, the average, which we all know is just adding all the numbers up and dividing by the number of them. The variance, which you read about, which basically tells us how spread out the data is, and then the standard deviation. So let's do some definitions. Let's kind of define these more generally, and then we'll do an example with, some grades of tests or something. So consider experiments with results that are numbers, and we're going to call those numbers the outcomes. Okay, so here's the idea here. So I can't help myself. So we have experiments and we have outcomes. So the example that we're going to look at is, let's say that I give a test. That's not an unusual thing in my area of work. And let's say that these are the scores on the test. I have a 60, 70, 70, 80, 90, another 70, another 90, another 80, and how about 100? Okay, maybe one more 90. So if these are obviously I have a class of 10 people in this scenario, and these are my grades. So what we mean by experiment is if I were to grab one of these exams at random, that's my experiment. So my experiment is I have all 10 exams on my table. I grab one of them and I look at the number. So that's my outcome. So if I repeatedly do this, right, I have some probabilities involved, and that's what we're going to define right now also. So, what is the idea? If I keep picking exams over and over, I probably need to go get a life. But if I'm sitting in my office and I have 10 exams face down and I keep picking them out, what is the probability that I'm going to get a 70? Or what is the probability that I'm going to get an 80? Something like that. That's what we're looking at. So let's do a little bit more notation here. Let's this is really getting into some common math notation. A1 through AN equal the outcomes of the experiment. Okay, so in our case, what are my possible outcomes? Well, 60, 70, 80, 90, or 100, right? Those are my outcomes. And then we're going to look at P. We are going to say that's the probability of one of those outcomes occurring. So probability of each outcome, we'll write this a little nicer here, as a relative frequency. And so you saw that in the book also. Relative frequency, it's just the frequency of that grade relative to how many grades I actually have. As a relative frequency of A sub I, and I'm not going to write this, but I want to note of this probability is if we were repeating the experiment often. Okay, so probabilities are interesting things because we could say, the probability of getting a 70 is 3 out of 10. Well, yeah, that's true if I repeat this experiment over and over. What that's saying is it's getting closer and closer to 3 out of 10. Okay, a couple notes here. Any of these P's, I'll just say P sub I because that'll give me, that represents any of these. Must be between 0 and 1 because they're probabilities, right? And we think of them as a decimal. So if it's a 1, that means I have 100% probability of it happening. If it's a 0, that means I have a 0% probability of it happening. Okay, whoa, what did I just do there? Sometimes this program, it's a lovely program, but all right. And another note here, if I add up all of these probabilities, what should they equal? Well, it should equal 1, right? Because really what is that asking? What's the probability of A1 occurring or A2 or A3 or A4 all the way up to AN? Well, that's like asking, if I pick an exam, what's the probability that the score is going to be a 60, 70, 80, 90, or 100? Well, that's 100% because I know that all my exam scores, those are all the possible scores for it, okay? And then our probability table, or our relative frequency table, but we're gonna say probability table. Okay, so our probability table, how we do this, we would have the outcome on top and then the relative frequency, or we're going to now call it the probability. So I have this A1, what is the probability that's going to occur? We'll say P1. Another outcome A2, what is its probability it'll occur? P2. I know this isn't like technically a table, but whoops. That should definitely be an A sub n and P sub n. So I just wanted to kind of, well, I have one more definition for us, but that's kind of the start of this. And then let's look at our next. We still have, these are still definitions. One of our definitions we're going to call expected value, and this is basically just going to be, or the mean, or the average. Okay, we call this, mathematicians, of course, are lazy, so we don't want to write expected value every time. So I'm going to put that E, and then we'll define this X here in a moment. But basically what this X represents is this represents the random variable or all possible outcomes of the experiment, okay? And what I mean by random variable is we don't know, variable means it can vary, right? Random means there's no set order to anything. So when I pick up a test, it's random and it just depends on which test I pick as to the outcome of that. Okay, so the other one that you read was the variance. So the variance gives us a way to, and let me go back to this definition. So I'll show you how this works here in a little bit, but this really does just give you the mean. If you take all of the grades and add them up and then divide by 10, that would be the same as basically finding the probability. Because if I have 3 70s, that's really like 3 times 70 over 10, which is really just like 70 times 3/10, and 3/10 would be the probability. Okay, we'll do one here. That's the only example I'm going to do for you, and then I want you to look at the book and look at the fun sheet and the solutions to the fun sheet. The variance, remember, is a way for us to talk about how spread out this data are. I think data is plural, right? So let's look at the variance. So the variance, remember, when you read it in the book, it's basically the average, we'll just put it right here, of the squares of the differences. So what this does for us, if you remember when we did, oh man, I have to write that first. And then here, M is your mean, okay, or your expected value. Handwriting's getting a little sloppy, sorry about that. If you remember when we did least squares, line of best fit, we took the distance between the best fit line and each data point. That is basically what this is doing. The mean, or the expected value, kind of tells us what the average is of the data that we're collecting, or what we would expect to get if we ran an experiment. And then I'm going to take actually each data point and I'm going to subtract that to see the difference between those two, to see how far away these data points are from the mean. We square it just to make it positive. That's the only reason we square it. There's nothing well, I think math is magical, but there's nothing super magical about that. We just square it because it keeps everything positive, and then we multiply by the probability of each one of those happening. So while the variance itself, again, I'm not a statistician, and the variance itself doesn't really tell us very much, I don't think. Something that does tell us kind of an interesting number is the standard deviation, which is just the square root of the variance. So the reason that's pretty interesting, if you remember from any of your statistics classes, and we use a little sigma to denote the standard deviation. If you remember anything from your stats classes, which I hope you do if you've ever had a stats class, that standard deviation basically tells us how far away from the mean we are. And when we do our example, I'll show you what the standard deviation is going to give us. Okay, so speaking of an example, oh, and really quick, X, this X that I've defined, right? Capital X. This is the outcome of the experiment. Excuse me. It's early, I need to probably drink some more coffee. And we say that X is something we call a random variable. That could just be a capital X. I'm just going to put the bars to really emphasize that it's not a lowercase x, it is a capital X. Okay, so let's do an example. Let me clear this out. Okay, so what I want to do the example with, let's build a probability table. I'm being a little lazy here, but you know, for the set of exam scores. Find the expected value, again, I'm being a little lazy, the variance, and the standard deviation. Okay, so here are my, if we look back, okay, so here's what I have. I have 60, 70, 70, 80, 90, 70. I wish I could just grab that, but we'll remember it. I remember what we have. So if I had to, whoops. Oh, calm down. Okay, so here's my exam scores, 60, and this might be in a different order, but let's say I had a 60, a 70, a 70, an 80, a 90, 70, 90, 80, 100, and a 90. Okay, that should be 10. 3, 6, 10. So I have a set of 10 things. So when remember what the experiment is here. The experiment is I grab an exam at random. Okay, I have all the exams sitting on my desk, and I'm just going to hang out here and grab the exams. So when I do the outcome and then the probability, let's think about this. So if I grab one of these scores at random, let's say a 60, we'll start off lower. What is the probability that that exam I grab is a 60? Well, how many total possibilities are there? There are 10. How many of those are 60? Well, just one of those. Okay, that's the probability that I grab a 60 if I repeat this experiment over and over. 70, how many of 70s do I have? 3. How many possible choices are there? 10. So I have a 3 out of 10 chance of getting a 70, and we can keep doing this. If I look at an 80, I have a 2 out of 10 chance. I know that's 1/5, but I'm going to just leave it as 2 out of 10. 90, the outcome 90, that would be 3/10. And then the 100 is a 1/10, okay? So this is what we mean by a probability table. So my probability table tells me the outcome and its relative frequency. Again, why is it called a relative frequency? Well, like for 70, for instance. Oh no, I don't want to open my Outlook. 70, for instance, right? That's the frequency of it is 3, and it's relative to the number of exam scores that I have, okay? All right, people. So let's find the expected value. So expected value, it's really just the mean or the average. So you can use your calculator if you would like. But I would like to see you at least set it up, and then you can use your calculator to actually find the solution, but I'm going to do 60 times 1/10 plus 70 times 3/10 plus 80 times 2/10 plus 90 times 3/10 plus 100 times 1/10. Okay? All right, and so our expected value here becomes 80. You can check on that. So my expected value is 80. That's my average or my mean, or if I keep, that's the expected value of this experiment, right? So it's kind of an interesting way to think about this, and it kind of makes sense if you look at our data and how it's spread out. If you look at 80, I have 3 90s to the right and 100 to the right of it, and then I have 3 70s to the left and a 1 and a 60 to the left of it. So it kind of makes sense, you know, that the data was spread out that way, and that 80 should be the average or the expected value. Then my variance, okay, I would do 60 minus 80. That's the difference between the possible outcome, right? The possible outcome. I'm gonna bring in the power of the ... The value of the possible outcome minus the mean, right? What this is asking is how spread out is my data. And when you get the variance here, we get 140. Now, personally, I don't see a whole lot of, I was going to say a whole lot of value in the variance. There is value in the variance, but when I look at 140, that doesn't really tell me very much. Does that mean it's spread out? And what I mean by spread out is if I get an expected value of 80, does that mean all 10 scores were between maybe like 70 and 90, right? Or were maybe all of my scores between like 50 and 100, or maybe 0 and 100? I just happen to have most of them around 80. That's what the variance does for us. How close, right, are the scores actually to the mean? Because I could have, you know, I could have a 0 test and a 100 test, and my mean would be 50, but 0 and 100 are quite far away from 50, right? Whereas I could have a 40 test and a 60 test, and my mean would still be 50, but clearly 40 and 60 are closer together. So as a teacher, you know, if I'm thinking of variance, I care about that, right? Because I care, are my exams, do I have an 80 because they're really, really close to 80, or do I have an 80 because some people really got it and some people really did not? Okay, so what helps us a little bit more with that is the standard deviation. So I'm just going to do this on my calculator really quick. And we get the standard deviation to be 11.83. And I don't think they discussed this too much in your book, but if you look at, you know, a normal bell curve, what that standard deviation says, so if this is my 80, if I went about 12 above, and so 92, and 12 below, 68, the majority of my scores would lie within that interval right there. So that's what I like about the standard deviation. I think it makes a little bit more sense. The majority, I don't remember the percentage, like 68% maybe, lie within one standard deviation of the mean. Now, if that standard deviation, of course, was smaller, then that tells me that my data is closer to the mean than if it was larger. So I hope this helps. I hope this kind of makes sense. As always, please let me know if you have any questions as you look at this. The homework's pretty short, but I want to make sure you understand it. So make sure you do the fun sheet also for extra practice, and enjoy.